This is eDefense, the world's largest earthquake simulator. It is a shake table that can support a high-story building and rapidly move side to side, up and down, to test its durability and note the vulnerable aspects of the structure. Since its release, the simulator has conducted hundreds of tests involving various buildings, scenarios, and forces to find a solution on how we can make our buildings more earthquake resistant. Because the need for this simulator, unfortunately, continues to grow. The eDefense simulator is located in Miki City, near the city of Kobe, Japan. The placement has an important reason behind it. On January 17, 1995, the city of Kobe was hit by one of the most devastating earthquakes, the Great Hanshin. It killed more than 6,500 people and left 300,000 people homeless. Thousands of homes were destroyed, with economic losses estimated at $100 billion. This earthquake, along with previous ones, became a reason for the government to gather the brightest minds in Japan and develop a plan for earthquake disaster prevention together. The parties agreed to create a machine that would simulate earthquakes for testing structures to find weak spots and reinforce them to withstand earthquakes in the future. The eDefense opened 10 years later in 2005. Their first ever test was to compare two traditional Japanese wooden houses and shake them at the magnitude of the Kobe earthquake, which measured 6.9 on a magnitude scale. However, one of the houses had been retrofitted with reinforced materials, such as braces, beams, and metal joints, while the other had no reinforcement. Needless to say, the Japanese house with no support collapsed like a house of cards. But how does it shake the structure exactly? The main part of eDefense is a 65-foot by 50-foot shake table weighing 800 tons. It is accompanied by 5 hydraulic actuators on each side, which move the table side to side. There are also 14 more actuators at the bottom, which move the table up and down. Powered by high-pressure oil, these giant cylinders shake the structure rapidly and test the objects. However, those actuators can only move in one dimension, meaning if they were just fixed to the table, they would break the table as there is no flexibility. Engineers solved the issue by designing special joints that are responsible for transferring the force from the actuators to the shake table. This whole setup allows scientists to simulate any possible scenario with various magnitudes and determine effects on different buildings. We would be happy if such facilities didn't have to exist. But, truth be told, we are probably going to need more simulators like this in the future, because you never know when the next earthquake is going to hit, which is what recently happened to Turkey and Syria. On February 6, 2023, southern Turkey was hit with an earthquake magnitude of 7.8, the most destructive earthquake to hit Turkey since 1939. The earthquake left over 3 million people displaced, damaging 230,000 buildings and completely wiping out 10,600 houses. The official reported death toll is 44,374 people. This event is a painful reminder that earthquakes pose a huge threat to unprotected people around the world. Building and using such simulators has become a necessity to build safe and resistant homes to save as many people as possible.